So without much ado, let's jump into our curriculum for today. We're going to talk about collections and sequences. Okay, let's check it out. So I'll see if I can get this done in 30 minutes, just to talk through it, maybe 45 minutes, and then we take a break, and then we jump into a lot of practice. All right. So data structures, again, is what our focus will be on today, collections and sequences. So what are going to objectives? We'll talk about complex data structures. Actually, what I meant to say here is complex data types. Complex data types, we talked about data types on the first day, but now data types become more complex. We need to put them in data structures. So data structures, definitely, I don't want to say complex data structures. And the two main types, the sequences, which you can see include arrays, lists, and tuples. And we have collections, which are sets and dictionaries. We'll talk about how to create and use them, also manipulate them, and some of the operations, like the functions that each one of these collections, or should I say data structures, do have. So at the end of the day, we will be able to learn about sequences like lists and tuples. We'll also learn about collections like sets and dictionaries. Now, let's go back again to the very beginning. Oops, I think I lost my video here. All right, so let's go back to the very beginning when we started creating variables, right? We remember variables are a space in memory that we, just like, you go and open a bank account and they give you a particular location for your bank, or if you go and open a vault account, depending on what you want to save in the vault, if it's jewelry, or if it's documents, or if it's bags of gold, or if it's cash, they'll know what amount of space to give you. Last class, we were looking at players that were playing dice. We had to create player 1, player 2, player 3. Each time, that means you're saving space in memory. So it becomes cumbersome when we have multiple, many variables. So sequences help us to be able to group all these variables and put them into one container, into one structure, what is known as a sequence or a data structure. So rather than having each one of them and keeping track of each one of them all the time, we just have a structure. Let's say instead of having 11 players with 11 different variables, we just have one team. That team has 11 spots for those 11 players, and we just keep track of that one team, and we keep changing the numbers of the players and so on. Does that make sense? So again, sequences, there are 3 major types. We'll talk about them shortly, but you have arrays. Arrays are not built in. Remember how we talked about last class, how we have functions that can be built in or user defined? So arrays are not built in into Python. So if something is not built in, we usually have to import it. So if we have to use arrays, we have to import it. But lists and tuples are built in to our Python. So we'll talk about all of them shortly. Let's jump in quickly. There you go. So what is a sequence? A sequence then is, like I pointed out, a set of variables grouped together. Okay. The variables usually have a position, which is known as an index. It's zero-based, meaning that the index always begins from 0. As you can see here, the index is starting from 0. Here we have 8 different values that we want to keep track of. These values are known as elements or items. So the element on index 2 is 30. The item at index 4 is 50. All of these belong to one array or one tuple, which we'll talk about shortly. The difference between the two, though, is arrays, like I said, they are not built in, so we need to import them. So if you want to import an array, it's always good to consider using NumPy. NumPy is a library. We talked about libraries. The reason we use NumPy is because NumPy is a library that has a lot of functionality in it. What we can do is pull that library and just pick up to get a particular function or a particular class out of it, or a particular module. In this case, the module will be arrays. Okay. So arrays, again, question error.
So if you could help simplify what an array is it just a 2-dimension? At least a 2-dimension?
Arrays could be 2 or 3 dimensions. So think about, say, in a soccer team, let's say in a soccer training room, right? All the players have their separate lockers, or in a police station, or in a school. All the students have their lockers. Each student has a locker. That space is fixed, and you go in there and put your items in there. The item that you put in there is the element, but that position is the locker. So it's fixed in, you could have multiple dimensions, but for us to start in a simple sense, it will be just 1 dimension. Okay. But
okay. When you say, I just want to kind of have that a bit clearer in my mind.
Yes.
So again, I'm just trying to compare that with your list, right?
Yes.
I see that the list is you have multiple items, but in just like one direction, 1 dimension.
Very good.
Is that making sense? I just want to try to clarify that for myself.
Yes, to clarify it, I'll help you again to clarify it even better, because after this, we'll talk about the list. But for now, I want us to start with the arrays, because the arrays are the basic ones.
Okay.
And once we understand the array, when we get to the list, I will definitely point out the differences between the arrays and the list, including the tuples and other different data structures as well, right? But for the arrays, let's just think about it as maybe a parking structure. You have 10 cars that have to park in there. The first car comes in and parks in, it's a Mercedes. The second car is a Ford. The third car is a Benz, or the fourth car is a Jaguar. and so on and so forth. So all those cars are parked in a fixed location. If we want to say which car is parked in spot number 3, we give it a particular name or we get the value out of it. So those are fixed, okay? But for arrays, it's important to know that arrays have to take a uniform or homogeneous data type. So all your arrays have to be either integer or double or string. You cannot mix and match them, okay?
Mm-hmm. So that slot that belongs to a Mercedes, you said is fixed.
Yes.
Is it possible to assign that slot to something else, or it's just going to be for the Mercedes?
Very good point. So there are a few things that we're going to talk about also to clarify that. When it comes to data structures, the main thing we want to talk about is the type of the data. Is it homogeneous or heterogeneous? Is it going to be the same all along? So if it's going to be a car, you have to be a car. You can't come in and park an airplane in there or come and park a boat, right? So that's the data type. Another thing we have to talk about is it mutable? Can we change it or can we not change it? So when we talk about all of those different data structures, then I'll be able to clarify again which ones are which so that it paints a clear picture, okay? But for now, since we're talking about just arrays, it's challenging for me to compare it with the others without mentioning it yet.
Okay, I'll hold my question. So
okay, good. So yes, so those are the two things I talked about the type of data. Is it uniform, as we see here with arrays, or with tuples? Tuples have varying data types, meaning you can have 10, you can have boy, you can have 30, you can have 7.5, you can mix and match whichever, whether it's an integer or a double and so on and so forth, okay? But with tuples also, they are built in and they come with Python when you install it. So if it comes with Python, that means you don't have to import it, so you're good. But with tuples, they are not mutable. You cannot change it. Once you've created it, it's in there, it's fixed. With arrays, you can change it. I don't want us to focus on arrays because we're probably not going to use arrays a lot. You rarely use arrays. That's why I just wanted to brush on it and jump off. And the tuples also, they're just comma-separated values. We'll talk about how to create all of them at the end of the day. But you can also use tuples to assign multiple variables, which again is something that we'll talk about at the end of the day when we get to dictionaries. So one thing to note though is for arrays, since we're not going to talk much about them, this is definitely not very clear. For arrays, when you want to create an array, once you import it, you can import an array. When you want to create it, you need to specify the type of information you want to put in there. If you're creating an array, do you want to put in integer or do you want to put in string? Do you want to put in float? Do you want to put in double? So you have to do that in the creation. So I'm not going to talk much about that now, but we can practice some of it later on when we come back after our break. So again, the first two data structures, arrays, they're not built in, they're not native. You have to import them for you to use them. They only use homogeneous data types. And if you prefer using scientific methods or numbers, you can use NumPy to import it, or maybe SciPy or Scikit to be able to do that. Now, tuples again, they have different data types. You can mix and match, but know that you cannot change it. So for instance, a tuple, when you might want to use it, is say you want to put in a particular location of a city. In that, you have to create a tuple because the location will take the longitude and the latitude. If you change the order of that, then you're going to have a separate location. So longitude and latitude, where it intersects, will be where the city is. So that would be an example of where you use a tuple because it's fixed. An array, you might want to use an array if you want to save space. Say you want, obviously, when you go to the store to download an app or the app market, you don't want to download an app that is very cumbersome. That's going to take up all the space on your computer or on your cell phone. So when, as a developer, you want to manage the size of your application to make it efficient and more performant, then use an array if you don't really need to use a list. Otherwise, you should definitely use a list. What is a list? A list, again, similar to those tuples. The main difference is a list, unlike a tuple, is mutable. You can change it. Everything else is the same as a tuple. So if you don't need something that's fixed, like the location of a city, then you might want to make sure that you get a list. It's mutable. You can use varying data types. That's totally fine. But a string, what is a string? We started using strings from the onset. A string is also considered a sequence. A string is considered like a list because you have a string of characters. For instance, if you have Python, in this case, Python would be a string of characters with a length of 6, right? The first index, the 0 index is P. The first index is Y, and so on and so forth. But also know that you can count indices backwards, okay? For every sequence or set, you can also count the indices backwards. For instance, -1 would represent the last item. -2 would represent the last but one item, and so on and so forth. So strings, again, are very, very powerful in Python. Next week, our next class, we're going to talk only about strings. Why is that? Because strings have many functions that we can use them, and strings are things that you use a lot. If you're going to be looking at text files, or if you're going to be looking at a lot of data, you'll need all those functions in strings. But remember that a string is a list. So everything that you can do with a list, you can do with a string, except for the part that the strings are not mutable. So if the string says it's Python, you cannot go in and say, change the very first element or the 0 index, change it from P to C. It's going to give you an error and say this is immutable. So what you need to do is create a new string altogether that has that different value in the first index. Does that make sense to everyone?
So if you have a list of strings, can I say that? No.
Yes.
A sequence of strings. Okay, I don't know what that you use, but I guess you know where I'm coming from.
Yes.
If you have Python, comma, C++, comma, JavaScript, comma, C, comma, can you switch the indexes? Like if we start with Python, then obviously it's 0 as we see here.
Yes.
But can we replace that entire Python with another string, like replacing it with maybe SQL or something?
Definitely. So in that case, you're looking at a string as an element. You're not looking at the string as the entire list. So every element in your list, you can change it. That's why lists are mutable. Does that make sense?
Good. Yeah. So it's element string. Okay, good. I got it. Thank you.
Excellent. Excellent. So yes, in this case, P is the element, but instead of Python, if you had in place of P, you had Python. In place of Y, you had 23. In place of T, you had SQL. In place of H, you had Azure. In place of O, you had AWS. You can always change each one of them, and we'll look at that in the afternoon, or should I say in the second half of today, when we actually start practicing a lot. Sounds good? So that's the main thing with sequences, those 4 different types. Okay, we started with arrays, which are not native with Python, and then we talked about tuples, which are fixed, you cannot change them, and they take varying data types. That's totally fine. And then we talked about lists and strings. Strings are also lists, but strings cannot be changed. Lists can be changed, unlike tuples. Meaning, when I say change in Immutable, I'm talking about the elements or the items within the list. All right. So let's go on and talk about collections.